Today, we will be traversing a haunted wasteland. Welcome back to a new episode of Programming Problems. Let's begin. As we are crossing the desert, we find a pouch which is labeled Maps. Upon inspection, we find that it is full of documents, including our puzzle input. We learn that we are supposed to navigate a network of nodes, where at each node we either go left or right, based on the directions at the top of our input. Assuming that we start at the node which is labeled AAA, then how many left and right instructions do we have to follow to arrive at ZZZ? Here you can see the input visualized as a network of nodes. The transitions are labeled with left and right. Let's visualize the transitions as we step through the directions as well. Let's start at node A. At the first step, we go left, which brings us to node B. Then we take step number 2, which is again left, so we go from B to A again. Step 3 is where we go right, which brings us to B. Then step 4 is left again, step 5 is left as well, and step 6 is to the right. Here we see that we finally jump to node Z. Note that as we went through our directions, we cycled through our inputs directions. So, if a step index is beyond the length of the string, then we just start over at the start of the string again. This is equivalent to just repeating the string into a longer string, as shown on the top right. If you haven't already, now is a good moment to pause the video and try to solve the problem yourself. Ready? Let's continue. The problem description gives us a very clear root node, or a starting point. Next to that, we also get a very clear target destination and instructions on how to traverse the graph. So let's just do the traversal. In the outline, you see that we just parse the input as always, and we split off the directions from the list of lines. The nodes we get via the parse nodes function, and then when we have them, we simply say that the number of steps gets returned by traversing the nodes. The structure that I propose for today's problem is a simple dictionary which mimics the structure of our input, as shown at the bottom. Every node's label is the first 3 characters on an input line, and we make the labels the keys in the dictionary. The values are, then, per node, the labels of our neighbors on the left and right stored as a tuple. Traversal is done based on the instructions, where remember that as we step through our graph, our step index can become larger than the length of the string. So we start on our node AAA and we initialize steps to 0. Then, while our node is not ZZZ, we keep updating the node. If the direction is to the left, we take index 0 from the dictionary's tuple. If the direction is to the right, then we take index 1. Note that looping through our instructions is as simple as taking the steps modulo the length of the direction string. For part 2, we find that we remain lost in the desert. After examining the maps for a bit longer, we learn that the number of nodes ending in the letter A is equal to the number of nodes ending in the letter Z. Suppose that we start at all of the A nodes at the same time, then there should be a way to follow all paths through our graph at the same time until all those paths simultaneously end up at Z nodes. Now the question then is, how many steps does it take before we're only on nodes that end with the letter Z? As for part 1, let's take the example from the problem description and we'll step through it one step at a time. So, we'll start at the green nodes and we'll traverse until all of our trackers are on the blue nodes at the same time. Let's start with the first step. We go left, then we'll go to the right. In step 3, we'll take another left, and in step 4, another right. Once more, a step to the left, and finally, on step 6, we'll take a right. Here we are in a state where all our trackers are on the blue nodes. It took us 6 steps to get here. Now, I want to point out that the description in this video is maybe a bit on the short side, but especially if you read the problem description on adventofcode.com, then the way that the question is asked, in combination with the example which we just visualized, provides a huge hint to today's solution for part 2. Specifically, these paths form repeating cycles. Let's use that to our advantage in today's solution. Anytime that we have cycles in these types of problems, there is a chance that we're going to have to deal with number theory, especially if it is about repeating cycles and figuring out when these cycles line up. Take, for instance, these two cycles of length 2 and 4. Let's assume that we're already on the spot where we line up on the blue Z nodes. Taking one step to the next node in our cycle puts us on two green nodes where we're not lined up. The next step has the small cycle again on the blue node. Next, they're both on green nodes again. And then finally, we found a number of steps where the two cycles are lined up again. Finding this length where the two cycles line up is also called the least common multiple. We'll do a deeper dive into number theory in some other video, but for now, let's see how our solution outline changes. We of course start the same where we take in our inputs, but then we also collect all of the nodes from the dictionary which end with A. Then, for every one of these nodes, we traverse the graph individually. At the end, we'll have a list of cycle lengths, which we'll just need to find the least common multiple of. Finding that is trivial, using the function from Python's math library. Of course, a minor detail here is that traverse no longer uses the magic value AAA as its starting node, but instead gets it as its input. However, for the rest, this function remains the same. And now you too should be able to get 2 more stars added to your collection. Thank you so much for following along, and I look forward to solving more Advent of Code problems over the weekend. I hope you do too.